2010 was a very pivotal year for us when we decided that we're going to become much more focused, and we knew that we wanted to focus on open source infrastructure, but we weren't sure what to pick. And at the time, Amazon was very popular, and a whole bunch of kind of open source alternatives emerged. There was CloudStack, it was OpenStack, Eucalyptus, OpenNebula, a bunch of stuff. And we looked at all the stuff, and of course our engineers chimed in, and they said, we should definitely do anything but OpenStack because it's total crap. It's written in Python. It doesn't work. There's no usage. Most likely best candidate, let's do CloudStack. It's Java. It's very good interface, 200 plus users. It's got everything going for it, really good, elegant code. Let's do that. So, we kind of weighed, but ultimately figured that maybe, betting on the community would be important. And we decided to put our eggs in the OpenStack basket. And in the next 2 years, the following happened. And today, you can argue indefinitely whether or not OpenStack is crap and whether or not, it's working well or not. But if you want to build an open source private cloud where you're orchestrating VMs, and you want to hire people that will be able to do that or will be able to support that, good luck trying to hire people that will support CloudStack or OpenNebula or Eucalyptus. All of these things today are largely gone, and for that specific use case, we have OpenStack. Fast forward maybe 3-4 years from that date, and again, we are kind of in the same situation where Docker and immutable infrastructure are now becoming a thing, and our team is building kind of a new architecture for delivering OpenStack. And the idea is that we want to containerize all of the services, deliver them in immutable containers, therefore greatly simplify the lifecycle management of it. And we're thinking of what container scheduler substrate should we use to actually re-architect our OpenStack distribution. Again, same exercise. Of course, the one that's been around at that point for a while is Mesos, but Swarm is kind of also popular among developers. So, and just recently, like Kubernetes is released, and it's this kind of toy that came out of Google. Nobody knows what it is, right? So, of course, our developers looked at the code. Mesos really solid, written in C++, been around for 10 years, scales to thousands of nodes, very good two-layer scheduling. Everything's awesome, right? Kubernetes, like, what is this crap? But again, from a community standpoint, the dynamic looked like it was back then already in favor of Kubernetes. So we made a choice in favor of Kubernetes at that time again. And of course, this is how things have played out up to today. And again, if you're doing anything with container scheduling, I would argue if you chose Mesos, and I know that Netflix uses Mesos, but hiring people to maintain anything Mesos-based is a much bigger challenge than if it was based on Kubernetes. So ultimately, the key point I wanted to make is that a lot of people see open source as like a licensing model or like a model for developing software even. But what's very important about open source in my view is that it's a framework for achieving consensus on a solution to a broad problem. So when we're trying to get into like the open source scene in the beginning, most of our engineers, they just hated it. And the reason why they hated it is because you go in and you say that here I'm gonna, I wrote this code, please merge it for me, and then some idiot on a mailing list comes out and says, you wrote it wrong, you have to do it differently. It's like, he doesn't know, and all this arguing, so it's so slow. And I'd rather just do it myself, forget about all of these open source people, and it'll be the best solution ever. Now, the problem is that when it comes to this kind of generic solutions, this consensus has to be reached at some point. So either I take it and I write it as my proprietary solution, and then after it's there, I have to go and convince other users and that might be pre-sales people, sales people, marketing people, maybe developers, to explain that this is a solution is good. Or I can do it on the front end. There is no way around it. You have to get the broad buy-in around the solution that you've developed. And just in the open source world, you get that buy-in ahead of time. So it takes maybe a little bit slower and longer, but ultimately the product of it is better. It's kind of like you can build a house really fast without going to an architect or spending any time on permits. But then this house is not going to be great necessarily. It's the same thing, exact thing with open source, in my view. So now let's talk a little bit about the competition, or I don't know if it's in competition. It's more like alternatives or various other solutions that can stifle Spinnaker from becoming a de facto standard. And by the way, I wanted to point some of these things out because I think that it's important for us as a community to be aware of all of the things that are out there. Like walking the floor, of course, we're all living in a Spinnaker bubble, including myself to some extent. And I hear some people saying like, oh yeah, Spinnaker already won. That's it. Like we are the standard for continuous delivery. I'm not convinced that it's yet the case. And I think that it's important to kind of like open our eyes as to maybe why not. So the first, and I split everything into the categories, broad categories of like, I would say Spinnaker alternatives or competitors. The first and biggest one that, based on the conversations we've had with our customers, is basically Jenkins plus DIY. It doesn't have to be Jenkins, but usually DIY in a space very heavily revolves around Jenkins. And this is a quote from Citibank that is like one among many that has invested a lot into their own release management based on Jenkins, and it's very hard to displace. But I wanted to talk a little bit more about why I think it's a real competitor, because you can say that, like DIY is always a temporary phenomenon. It doesn't last. It can go away. This historically has been kind of the case. But I think that Jenkins plus DIY, when it comes to CD, is particularly sticky. And the reason why it's particularly sticky is because of this kind of value scale. So you can take any software, you can put it anywhere on this value scale over there, where on one side you have, the software has a lot of value in the code, and on the other side you have a software has a lot of value is actually in the best practices. And on the left side, or yeah, the left side for you, the examples like Linux, Android, MySQL, there's a lot of value in the code. But on the right side, you have solutions that are more of like business applications like CRM, supply chain management, ITSM. They are tied into the business process. And you can put any piece of software on that scale anywhere. And depending on where it is on that scale, the ease or how hard it is to displace the incumbent requires different dynamics. So if you put Spinnaker, I would argue that Spinnaker, and not just Spinnaker, but anything continuous delivery related, is probably somewhere a little closer to the part where the value is in the best practices, because a lot of the things that you do related to deployment is actually tying your business process into how the deployment works, and it's really hard to displace that investment that you've done. So like, try to think of like you've built something with Spinnaker. Like imagine somebody comes in and says, I have something much better. It's going to be probably try to go tell Andy, go throw away Spinnaker, go use some other standard. Probably not going to happen ever. Jenkins DIY kind of in the same bucket. So another big important bucket that I think it's important to be aware of is this thing called application release orchestration, which even has a Gartner Magic Quadrant attached to it. There's a lot of players there. What they don't have going for them is that most of them were not built in a cloud-native first fashion, which Spinnaker was. They're more kind of an extensions of, how do you build your business process, an extension of CI. But they have been around for a long time. They all know that continuous delivery and cloud-native continuous delivery is the thing. And most of these guys have repositioned themselves as now continuous delivery guys and are doing something that one way or the other intersects with the continuous delivery space. And you can really split all of these guys into two categories. That's kind of my subjective way to split them. One is release process-centric ARO, and the other one is orchestration-centric. And the orchestration-centric are the guys that were in configuration management space, but they have built some sort of continuous delivery functionality on the top. So Puppet has Puppet pipelines, Chef has Chef Automate, Red Hat has Ansible Tower and OpenShift. All of them are kind of dabbling in that space. And then finally, the third category that is also fairly credible is CD as a service. And CD as a service is split into two buckets. There is a CD as a service that is part of some IaaS, so Google Cloud Build or AWS Code Deploy, or there's pure play guys like Bamboo, Circle CI, which people say it's CI, but not really. They also do CD. Harness, which are here, are pure play hosted CD platforms. So now if you try to put all together, right, this is my subjective read, and I don't know, I'd be curious to hear if you guys agree on it or not, like how much a solution is used today and how likely it is to be used in the future, and map that to some sort of characteristics. So if you look at Jenkins DIY, it's very common. Jenkins is everywhere. There's some sort of DIY around it. Will it be used forever in the future? I think somewhat, but I don't think it's going to be the thing. I think that the continuous delivery space in general is complicated enough and big enough that there's going to be substantial value in wrapping yourself around some sort of out-of-the-box standard approach rather than just DIYing it. So while it is still there today, I don't think it's going to stay like that forever. Second is configuration management-centric ARO, application release orchestration. So like Chef Deploy or Puppet pipelines. So I think that these guys are everywhere. Everybody uses configuration management in some capacity. As far as going into the continuous delivery space, not sure, because most continuous delivery solutions will not be using a single configuration management stack. Most likely, you'll have parts of the organization that's Chef, parts of the organization that's Puppet, parts something else. So because of that, I don't think that going into the future is going to be the thing. Next is pipeline-centric or orchestration-centric release management software from that Magic Quadrant. So according to Gartner, it's used by 20% of the people today, 20% of the enterprises. 80% they project in 2023. I don't know how you can exactly believe these numbers, but I do believe, and I think that popularity of Spinnaker itself shows that having a very good, flexible, sophisticated pipeline engine to kind of embed your release business logic into it has a lot of value. So that part going into the future, I think, is going to be very important. Hosted tied to IaaS, I don't know. I mean, they're kind of used, but not too much. And I don't think it's going to be used. It's going to be the standard, simply because you want to be deploying across multiple cloud targets. Most people will not be just doing Amazon or just doing Google. So there's a camp there that says that it's just going to be only one. I don't think it's going to be only one. And as such, I think that continuous delivery has to sit above the deployment target. And finally, hosted pure play, I think that probably is going to be used a lot. And it does have a shot at becoming a standard, simply because kind of the hosted model as a delivery model is historically been proving itself out as the way to go across all layers of the stack. And pure play is important for all the reasons I described. So if you look at kind of this graph, like where do you want to be and how does Spinnaker map today? I think Spinnaker has a lot going for it to actually be right there. So it is cloud agnostic, it is configuration management agnostic, and it does have very powerful pipeline and workflow. So it's got a lot going. Now let's talk a little bit about some of the things that I think we could improve on, and some of the obstacles or threats, so to speak. The first one is Kubernetes and all of the solutions that are doing continuous delivery around Kubernetes. Now, the reason why that's a threat is because, like I said, when I was talking about Jenkins DIY being the biggest competitor and being hard to displace because it's tied into the business process, one of the ways that you displace the incumbent is when there is a new deployment substrate out there. So the reason why Spinnaker became popular among, I've talked to a bunch of Spinnaker customers, is because you need to deploy to cloud, right? We never deployed to cloud before. So how do you do that? Well, wow, we have this new tool. OK, let's do that. With Kubernetes, it's kind of the same thing, right? Kubernetes is becoming a very popular deployment substrate, and there's a bunch of guys that are just squarely focusing on doing continuous delivery for Kubernetes. Not to mention that Kubernetes itself is also building its native tooling and API objects for handling ever more sophisticated deployments. So what does Spinnaker lack to be one of these guys on the left there that are actually becoming the Kubernetes deployment tools? So I think that these are the three areas that all of these guys on the left have that Spinnaker has to a varying degree. So you have to be lightweight. If you want to be developer friendly. By lightweight, I mean like a developer can take this thing, set it up really quickly, and start playing with it and try it out. So if you talk to an ops guy, he says it's completely not relevant because, hey, it's my ops team is running Spinnaker. Why does developer care? Well, developers have a lot of influence when it comes to making decisions around tooling, when it comes to greenfield initiatives. So if they've never touched something like Spinnaker, or never seen it, and they can't even do it, they're not going to recommend it as the thing to deploy to Kubernetes. And if they can't download it, if it's not lightweight enough, they can't play with it, they probably will never have seen it. And I bet you anything that if you go to Kubernetes KubeCon and you ask people what are they doing for deploying to Kubernetes, not so many of them today are going to tell you that they're using Spinnaker. GitHub-centric, so making some progress with declarative delivery. But again, I think that historically, Spinnaker was built with, it's kind of both a benefit and a curse, but very kind of UI heavy and make it very simple and out of the box, and was lacking a little bit in the GitOps and declarative delivery space, which now is being remedied. And finally, kind of Kubernetes centricity. So we have, V1 provider, which clearly was not very welcome by the Kubernetes community simply because you can't use Kubernetes primitives. And now we have a V2 provider, which I feel kind of swings almost like all the way in the other direction, where you can do anything, but to some extent it kills a lot of the value and simplification and abstraction that Spinnaker brings to the table. So I think that going forward, probably some tuning still needs to happen in the Spinnaker community by the Spinnaker users to get that right. Now, the one big thing that Spinnaker has going for it against anybody in that, we are VCD for Kubernetes camp is that it's natively designed to be working with multiple deployment targets. So the big know-how in continuous delivery that Spinnaker brings to the table, in my view, is this marriage between sophisticated pipeline engine to build to kind of embed your deployment logic and awareness of the deployment target, which is, today is implemented for Cloud Driver. Marrying these two together and being able to orchestrate the deployment target and with the understanding of the deployment logic, that's basically the cool stuff of the continuous delivery. And you'll never be deploying to a single deployment target. The world is not going to be all on Kubernetes. So that Spinnaker's got going for it out of the box. But now that we're on this topic, I wanted to touch on, the deployment targets and the whole notion of pluggability in Spinnaker, which I think is another potential obstacle that we as a community should focus on and work on improving. So, multiple deployment targets is very important, and we all agree. And, I think that if you listen to Andy speak, or if you talk to anybody in the community, everybody agrees that like one of the core architectural tenets of Spinnaker today and going forward is pluggability. Yet if you look into certain spaces, into certain kind of areas of how this pluggability is implemented, I think it's still imperfect. If you go to the Spinnaker documentation, is how do I build my own cloud driver, that's literally what's there on the website. It's very hard to do. Don't try it unless you're expert, which is true, because building a new cloud driver or changing cloud driver, like the pluggability concept that we have today, means really forking Spinnaker, changing some of the components, then merging them back. There isn't really an out-of-the-box plugin mechanism. I can't write my plugin and have my cloud driver, and Spinnaker will naturally just take it, right? Like I can write my YAML file for the Kubernetes deployment object, for instance. So that's another thing that I think we in the community need to work on. And finally, and this was an absolutely kind of pivotal, I think, conference in that Spinnaker has adopted, finally, formal governance. And I think that we started solving this problem already, but I think that still have ways to go. If you look at the number of vendors contributing to an open source project, and you compare, for example, Kubernetes to Spinnaker, 133 for Kubernetes, 16 for Spinnaker. And you can argue that actually it's great. We have so many contributors that are users. Let's have only users contribute. But I think that for an open source project to become a standard, you absolutely need multiple vendors involved. And the reason why is because people using, they are only willing and able to take on certain kind of solving certain tactical problems. So if I am a company using Spinnaker for my specific use case, I'm not going to be putting 10 people to build a pluggability framework for Spinnaker, or build a lightweight version so the developers like it. I don't care about that. But vendors absolutely are able to tackle long-term roadmap items. And today, out of the big vendors really capable of a muscle to tackle long-term roadmap items, we have Google and Netflix. It would be good if we had more. So now, just to sum it all up, this is kind of like where we are, in my view. And cloud agnostic, yes, everybody agrees that we are, but I think that from the standpoint of actually turning that cloud agnosticism into practical code, we could probably introduce some improvements. Config management agnostic and powerful workflow engine, absolutely. We are leaps and bounds ahead of everyone there. Developer friendly, not right now. I don't know if there is an easy way to solve this. Maybe something like the Jenkins X guys are doing, but I don't have an out-of-the-box suggestion. Easy to write plugins. I mean, you can. There's documentation on how to do it, but it's not like there's a pluggability framework for doing it. And finally, the commercial vendor community is still fairly limited compared to the projects that are standards. Like if you compare Spinnaker to Linux or Kubernetes or even OpenStack, which I know most people don't like very much, the vendor behind it, the community of vendors investing in it, is not quite there for Spinnaker. But I want to end on a positive note, and I want to say that in my view, software can always be changed. It's easy. It's not easy, but it's doable. What's very unique and what you cannot predict and you cannot kind of build a formula for and continue doing replicably is actually building communities. So you can't just say, you can build the best possible continuous delivery piece of software out there, put it in open source, and nobody will care. With Spinnaker, that's not the case. We're all here. We have already a big community. And 350 people have come here today to actually collaborate and figure out how we take this forward. This is a unique aspect that nobody has in the continuous delivery space today that I think we have to absolutely capitalize on and do our best to navigate some of these obstacles. That's all I had. Thank you.